Hello everyone, good afternoon. My name is Qodatullah Panay. I'm assistant professor in clinical biochemistry in Tehran University of Medical Sciences. Today we are going to talk about the lipids, their structure and their function, and different categorization and classification of lipids. Here is my email address and you can contact me if you have any question related to this session and other session which you had with me. First of all, I want to introduce the objective of this lesson, and after studying this chapter you should be able to define simple and complex lipids and identify the lipid classes in each group. We have different classes in lipid and you must know all of them. And also about saturated and unsaturated fatty acid, explain what are they and how the chain length and degree of unsaturation influence their melting point, and also give example about these type of fatty acid, unsaturated and saturated. Also we have different nomenclature for fatty acid and you should be able to know the nomenclature of fatty acids. And then explain the difference between cis and trans carbon-carbon double bond. We have two type of fatty acid related to cis and trans, and one of them is natural and one of them is a hazard for our body. Describe how icosanoids are formed by modification of the structure of unsaturated fatty acid. And also you must know different classes of icosanoids such as thromboxane, leukotriene, prostaglandin, prostacyclin, and lipoxin. There are many important compounds in our body which have a lot of function, and most of signaling in our body is done through these compounds. And then you must know about the general structure of triacylglycerol and indicate their function. Outline the general structure of phospholipid and glycosphingolipid and indicate the function of the different classes. The other type of lipid which is so important in our body and produce many important biological compounds such as steroid, hormone steroid, bile acid, and vitamin D is cholesterol. You must know the structure of cholesterol and recognize the cyclic nucleus common to all steroids. And in the last part of this session we talk about the four major group of plasma lipoprotein and four major lipid classes which they carry. And in the end of class we summarize all of the topic which we will talk about them. Lipids, biomedical importance. The lipids are heterogeneous group of compounds including fats, oils, steroid, waxes, and related compounds which they are related more by their physical property than by their chemical property. And they have a common property of being relatively insoluble in water and soluble in nonpolar solvent such as the ether and chloroform. And they have they are important dietary constituent not only because of the high energy value of fat, but also because essential fatty acid, fat soluble vitamin, and other lipophilic micronutrients are contained in the fat of natural food. Dietary supplementation with long-chain omega fatty acid is believed to have a beneficial effect in number of chronic diseases including cardiovascular disease, rheumatoid arthritis, and dementia. Fat is stored in adipose tissue where it also serves as a thermal insulator in the subcutaneous tissue around a certain organ. Nonpolar lipid act as an electrical insulator and allowing rapid propagation of depolarization waves along myelinated nerve. Lipids are transported in the blood combined with protein in lipoprotein particle. And lipid biochemistry is necessary for understanding of many important biomedical conditions, including obesity, diabetes, and atherosclerosis. And because of this reason, the understanding of lipid structure and function is so important for medical student, and also you must know the property classification and different function of lipids. Function of lipids. Lipids have a lot of function in our body, and different type of lipids have a different function. Here you can see some of these functions. Lipid such as a triacylglycerol can act as a storage form of energy, and also some lipids like phospholipids and cholesterol are a structural component of biomembrane. And other type of function of lipids are they can act as a metabolic regulator like steroid hormone and prostaglandin. Also, amphipathic lipids can act as a surfactant or detergent. Lipids can act as an electric insulator in neuron and also provide insulation against change in external temperature. Subcutaneous fat can provide insulation against change in external temperature. Lipids give shape and contour to the body, and also they protect the internal organ and help in absorption of fat soluble vitamin A, D, E, and K. And finally, lipids can improve taste of food. Lipids are classified in different way, and we announce with some of this classification. Here you can see lipids are classified to a different group. One is simple lipid, two is a complex lipid, and three is derived lipids. A simple lipid include fat and waxes, which are ester of fatty acid with various alcohol. Fat are ester of fatty acid with glycerol, oil or fat in liquid state. And waxes are ester of fatty acid with higher molecular weight monohydric alcohol. And complex lipid are ester of fatty acid which always contain alcohol and one or more fatty acid, but also have other group, especially phospho group. And they can be divided into three types: a phospholipid, a glycolipid, and other complex lipid. Phospholipid contain a phosphoric acid residue. They frequently have a nitrogen containing bases, example choline or serine or ethynylamine, and other substituents. In many phospholipids, the alcohol is glycerol, glycerophospholipid. But in sphingophospholipid, the alcohol is sphingosine, which contain an amino group. And about the glycolipid or glycosphingolipid contain fatty acid, sphingosine, and carbohydrate. And the other complex lipids include lipids such as sulfolipid and aminolipid. Lipoprotein also can be placed in this category. And the final type of lipids are derived lipids, which are formed from hydrolysis of both simple and complex lipids. They include fatty acid, glycerol, steroid, other alcohol, fatty aldehyde, ketone body, hydrocarbon, lipid-soluble vitamin, micronutrient, and hormone. Because they are uncharged, acylglycerol, cholesterol, and cholesterol ester are termed neutral lipid. In other type of classification of lipids, lipids are classified to four groups, including a simple lipids, a compound lipids or complex lipids, and derived lipids, and also lipids complex to other compound. In simple lipids, we have a two group, triacylglycerol or triglyceride or neutral fat, and also waxes. Complex lipids also have a different categorization, and in future slide you will be announced with this type of lipids, but here I want to summarize this categorization. We can divide the complex lipid to two groups, phospholipids and non-phosphorylated lipids. Phospholipids including lecithin or phosphatidyl choline, cephalin or phosphatidyl ethanolamine, and phosphatidyl serine, and also phosphatidyl inositol, phosphatidyl glycerol, and d-phosphatidyl glycerol or cardiolipin, and also plasmalogen and sphingomyelin are other type of phospholipid. And you can see here they have a different categorization, and it's not needed to learn this type of categorization. Just you must know these lipids: lecithin, cephalin, phosphatidylserine, phosphatidylinositol, phosphatidylglycerol, cardiolipin, plasmalogen, and sphingomyelin belong to the phospholipids. And other type of complex lipid are non-phosphorylated lipids, which include a cerebroside, globozytes, ganglioside, and sulfated cerebroside, sulfated globozyte, and sulfated ganglioside. And in derived lipid, we have fatty acid, we have steroid, we have prostaglandin, leukotriene, terpen, and glycol, etc. Lipid complex to other compounds including protolipids and lipoprotein. In a last classification, these type of lipid are in this group. Here you can see the structures of some common classes of lipids. Fatty acid, which the most property of fatty acid is that they have a carboxylic group, which you can see here, COO, and the hydrocarbon tail. Okay. In triacylglycerol, we have a glycerol. You can see this structure, which have a 3 carbon and 3 OH or hydroxyl group. This 3 hydroxyl group can bond to 3 fatty acid and produce the triacylglycerol. In glycerophospholipids, in addition to the glycerol and fatty acid, Also, we have a other group including a phospho or sulfo group, which also they can bind to different compound. Like here you can see it's bind to the choline and its name is glycerophosphatidylcholine. And glycerophospholipids uh, have a different classes which we will talk about them. And in sphingoglycolipids, instead of glycerol, you have a sphingosine plus fatty acid, and also they can include the carbohydrate residue. Okay, it's just for beginning of the structure of fatty acid and other type of lipids. Okay, fatty acid uh, are included in group of derived lipids. It is the most common component of lipids in our body. They are generally found in ester linkage in different classes of lipids in the human body. And free fatty acids are formed only during the metabolism. Fatty acids that occur in natural fat usually contain an even number of carbon atoms. The chain may be saturated or unsaturated. Saturated fatty acid contain no double bond, and unsaturated fatty acid containing one or more double bond. Fatty acids are aliphatic carboxylic acid and have a general formula RCOOH, where COH or carboxylic group represent the functional group. Depending on the R group, the hydrocarbon chain, the physical property of fatty acid may vary. Characteristics of common fatty acid are uh, given in other slide. About the classification of fatty acid, we have a different different classification of fatty acid, including depending on the total number of carbon atom, even chain or odd chain. Even chain, they have a carbon atom 2, 4, 6, and similar series. Most of the naturally occurring lipids contain even chain fatty acid. But in odd chain, they have a carbon atom 3, 5, 7, etc. Odd numbered fatty acid are seen in microbial cell wall. They are also present in milk. Depending on the length of hydrocarbon chain, they are divided to four groups. Short chain with 2 to 6 carbon atoms, medium chain with 8 to 14 carbon atoms, and long chain with 16 and above, usually up to 24 carbon atoms, and very long chain fatty acid more than 24 carbon. Depending on the nature of hydrocarbon chain, they can be divided in two groups, saturated fatty acid and unsaturated fatty acid. Also, in this group, we can divide them to four groups. In addition to saturated and unsaturated, we have a branch chain fatty acid and hydroxyl fatty acid, which they are not common. Saturated fatty acid contain no double bond and may be uh, estimated as based on acetic acid or CH3COOH as the first member of series in which CH2 group is progressively added between the terminal methyl and the carboxylic group. Other higher members of series are known to occur, particularly in waxes. A few branched-chain fatty acids have also been isolated from both plant and animal sources. Okay, here you can see some type of saturated fatty acid. The common name acetic, butyric, valeric, copric, lauric, myristic, palmitic, and esteric acid. The number of their carbon start from 2 and to 18. The most well-known of this type of acid are palmitic and esteric. The palmitic is common in all animal and plant fats. About unsaturated fatty acid, which they contain one or more double bond, they can divide it into three groups: monounsaturated or monoethanoic or monoenaic acid containing one double bond, polyunsaturated or polyethanoic or polyenoic acid containing two or more double bonds, and icosanoid, this compound derived from icosa or 20 carbon polyenoic fatty acid. And the icosanoids also include prostanoid, leukotriene, and lipoxygen, and also thromboxane and prostaglandin. Prostaglandin including prostacyclin and thromboxane. Here in this table, which I took from the Leninger book, you can see the different natural occurring fatty acid, their structure, property, and nomenclature. We have two different systems for nomenclature of fatty acid. The delta system, which you can see here, and also omega system. Okay, we start with lauric acid. The number of carbon skeleton is 12, and the structure you can see here, CH3 and CH2 10 times and COOH. They have a systematic name and common name, which we use the common name for fatty acid. The common name of this carbon is lauric acid. And you can see the melting point solubility in water and benzene. Benzene is nonpolar solvent. The other type is myristic acid with 14 carbon and melting, and also the solubility in water and benzene. The most well-known fatty acid is palmitic acid with 16 carbon, which is the product of a fatty acid synthase in our body and in animal and plant. In front of the number of carbon, you can see the number which here is 0. This 0 represent the number of double bond in their structure. And stearic acid include 18 carbon, and you can see the melting point and the solubility. Here you can see with increasing the number of carbon, you can see the increasing in melting point from 44 to 76 or 86 in tetraicosanoic acid. The eicosanoic or arachidic acid have a 20 carbon without double bond, and the melting point is 76.5. And the last type of saturated fatty acid is tetraeicosanoic acid or lingothrioic, with melting point is 86. All of these these fatty acid are saturated fatty acid because they don't have any double bond in their structure, as you can see there. And with increasing the number of carbon, the melting point is increasing and the solubility in water decreasing, as you can see here. But related to unsaturated fatty acid, you can see they started with 16, 18, 18, 18, and 20 carbon. Here, 16, 1 delta 9. 1 represent 1 double bond, and delta 9 is the position of the double bond. As you can see here, the numbering started from the last carbon or carboxylic group. The COH is 1 and 7CH2, 1 plus 7 is 8, and the next carbon is carbon number 9. For this reason, in carbon number 9 we have a double bond. And the systematic name is cis-9-hexadecanoic acid, or the common name is palmitoleic acid. And you can see the melting point from 63 degrees to 1 to 5 degrees with addition of just one double bond. In this fatty acid 18, 1 delta 9, you can see here carbon number 1 and plus 7, it's 8 carbon, and also the other next carbon is carbon number 9. The systematic name is cis-9-octadecanoic acid, and the common name is oleic acid. These two type of unsaturated fatty acid, 18 with delta 9 and 12 and 18, 3, delta 9, 12 and 15, are so important in our body because they are essential fatty acid, and their name is linoleic and linolenic acid, and they have a true double bond and 3 double bond. You can see in their structure here. Double bond here is on carbon number 9 and 12, and here is carbon number 9, 12 and 15. And the common name is linoleic and linolenic. And the final fatty acid, unsaturated fatty acid, is arachidonic acid with 4 double bond. They start from carbon number 5, 8, 11 and 14. You can see, watch this double bond, 1, 2, 3 and 4 double bond. And the systematic name is eicosa tetraenoic acid or arachidonic acid with melting point negative 49.5. Okay, what we must know related to this table? The delta system, including start with the number of carbon, and then the position of the number of double bond or unsaturated carbon, and also the position of double bond. When you have a zero in double bond, it means they are saturated fatty acid. The most known saturated fatty acid are lauric acid, myristic acid, palmitic acid, stearic acid, arachidic acid, and lingostric acid, which with increasing in the number of carbon, you have a increasing in melting point and also decreasing in solubility. Related to unsaturated fatty acid, after the number of carbon, we have the number of double bond or number of unsaturated. And then the number of the carbon number of which have a double bond or the position of unsaturated carbon. And they are most common unsaturated fatty acid, palmitoleic with 16 and 1 double bond, oleic acid with 18 and 1 double bond, linoleic acid with 18 and 2 double bond in carbon number 9 and carbon 12, and linolenic acid 18 with 3 double bond on carbon number 9, 12 and 15, and arachidonic acid 20 carbon with 4 double bond on carbon number 5, 8, 11 and 14. Also, for the memorize the numbering of the position of double bond, you can memorize after each carbon we have a 3 other carbon. Between 9 and 12, 3 carbon, 9, 12, 15, 5, 8, 11 and 14. The other nomenclature of fatty acid is the omega system. In omega system, we start the numbering of carbon from the methyl side, from this side, and based on the double bond carbon position, we can have a omega 6 and omega 3 and omega 7 and omega 9 in unsaturated fatty acid.